See here, all of these topics are done. Just tell me in the chat, yes or no. These two things are done, right? Yes, okay. And these reactions are done. What about this part? Halogens are less reactive towards electrophilic substitution than benzene. Explain. Are these questions done? No, fine. Take it. So we are going to start from there. It has been long time. 16 October and why halogens show E. Okay, fine. And what's today? Today's Wednesday. You guys have also done some questions, right? ठीक है. Now there are a few more parts. Write a question. Why or rather halogens are less reactive towards Se, that means electrophilic substitution, than benzene. Explain. See, देखिए, halogens are less reactive towards electrophilic substitution than benzene. So electrophilic substitution reaction, that means there is an electrophile which is positively charged. It will react with something which is negatively charged. If this negatively charged substance is very negative, is highly negative, then the reaction will be very fast. And what we can say that it is reactive towards Se. Fine. But when we have haloarene, it is attached with, please write the answer like this, due to strong minus I effect, strong minus I effect of halogens the electron density in benzene ring electron density in benzene ring decreases, and this slows the attack on electrophile. ठीक है? So because the benzene ring it is attached with halogen atom and has a very high negative I effect, the electron density will decrease, and if the electron density decreases, obviously an electrophile cannot attack very quickly. Taha, assalamu alaikum. How are you?
Walaikum salam. I'm fine, sir. How are you?
I'm good. I'm good. Alhamdulillah. आप क्लासेस अटेंड कर रहे थे ना ताहा?
Yes, sir. I left, I think, one because I had school, like after school classes.
अच्छा, you left one. Okay. By the way, timings have also been changed. I hopefully अब आपके लिए थोड़ा सा आरामदेह होगा.
Yes, sir.
Like all of those students who had used to face a bit of rush school से तुरंत आना उसके बाद classes and all. ठीक है, got this. Wrote this down. Mariam, Sufyan.
सर एक मिनट लिख रही हूँ।
अच्छा, ठीक. इस चैप्टर को खत्म करते हैं, है ना? एंड उसके बाद we are going to start with alcohol, phenols and ethers. चैप्टर काफी टाइम ले लिया, लेकिन चैप्टर I thought that it would have been completed because like eight classes, no? 8 classes.
Done.
Right, next. Now, this is an important question. Halogens are strong electron withdrawing groups, but haloarine give ortho and para products on electrophilic substitution reactions. Why? You know, where this question arises from, like, what is the what is the effect of electron withdrawing groups? So, generally speaking, the minus M groups are electron withdrawing groups, but haloarine is one of, like, rather I should say, halogen is one of those groups which shows electron withdrawing effect, but it is also plus M. So it is electron. Please don't write now. Hai na? It is electron withdrawing group because of minus I, but it gives ortho and para product because of plus M. And there is a very beautiful line written in NCERT that reactivity, how fast the reaction is going to happen, will be determined by minus I, but the orientation where the products will come or where the groups will be attached, those things will be determined by plus M, which is going to give you the electron density at the different carbon positions. But overall reactivity, it is going to be determined by minus I. Minus I does not have any control on where the electron density is. What minus I does is that it decreases the electron density completely from the benzene ring. If let us suppose we have X halogen atom, it decreases the electron density from the complete benzene ring. But if I compare the electron densities in the ortho, meta, and para position, because the ortho position gets plus M effect and the para position gets plus M effect, although these are also getting minus I and minus I, but the meta position it only gets minus I effect. So electron is only getting decreased from the meta position. From ortho and para, it is getting decreased a bit less. And that is why, even though this is only one case for halogen atom only, which is valid for halogen atom only, that it is an electron withdrawing group, but still it gives ortho and para products. And the reason is because it is plus M group and it shows resonance. Okay. इसके आंसर के लिए, like, this is how you have to write the answers ना. These words are important. First of all, we will make it clear that electron withdrawing group क्यों है halogen. Like the halogen atoms, these are electron withdrawing groups. True. So you can write halogens are strong electron withdrawing group. Why? Due to minus I. First thing we have cleared that it is what it is, a strong electron withdrawing group. What is the reason? It is because of minus I. But as they show resonance, In bracket, you can write plus M. Electron density increases at ortho and para position. Therefore, ortho and para products are formed on SE. अब उसके बाद एनसीईआरटी की जो लाइन है आप उसको लिख दीजिएगा इस तरह से. Reactivity is controlled by minus I, but orientation is controlled by resonance. Can you copy this down? Raise your hand once you're done. Waiting for Amna and Taha. Just waiting for Taha. Assalamu alaikum Amna, how are you?
वालेकुम अस्सलाम सर.
Okay. Amna, आप क्लासेस अटेंड कर रहे थे ना?
जी.
You were attending the classes, na? Like when I was absent.
Yes sir.
All of you are done, so you can move on. Now, electrophilic substitution के बाद we have a small topic of haloarine, that is nucleophilic substitution. Please write the heading. Of haloarine. लिखिएगा haloarine don't show SN nucleophilic substitution at room temperature. Due to following reasons. Due to following reasons. Now, what I will do now, I will explain you the and then we can write it down. Okay, so once I'm explaining, please don't write anything. Try to understand what I'm saying and just let me know if you understand it or not. Okay, first reason is that if we see the structure of haloarine, then haloarine has something like this structure. Halogen atom here. Please don't write this down. There is a double bond character here because of resonance. And since this carbon halogen bond, it gets a partial double bond character, this bond is difficult to break. This bond is difficult to break. And if the nucleophilic substitution is happening, then obviously CX bond will be broken and carbon nucleophile bond should be formed. So this should be broken until unless CX bond is broken, we cannot have the CNU bond. Now, because of partial double bond character, it is difficult to break. First thing is that. Okay. Then, even if it breaks, we will get something like this. We will get a cation, which is like this. And here we have positive charge on the carbon atom, and all the carbon atoms, this carbon, this carbon, this carbon, like 1, 2, 3, 4, 5 carbon atoms. All of these 5 carbon atoms are sp2 hybridized, which are electron withdrawing. They have higher electron activity, and that is why what is going to happen? They are going to withdraw the electrons, which will make this particular carbocation unstable. So the first reason is that we cannot break the double bond. Sorry, we cannot break the CX bond because of partial double bond character. Even if we break it, we will get a carbocation which is unstable. So right now we are thinking about SN1 type of reaction in which what happens, the bond breaks and we get the carbocation. So fine, if it cannot undergo via SN1, can it go via SN2? Let us see that. So if I have a nucleophile, then this nucleophile should come and it should attack on this carbon atom. Now this carbon atom, it has a benzene ring, and benzene ring, it has higher electron density because of the pi bond. There are 3 pi bonds, and because of that there will be higher electron density here. Nucleophile is also something which is having higher electron density. So both of these ring, benzene ring and the nucleophile will repel each other. And that is why the nucleophile will not be able to attack on the carbon atom of CX bond. Now, the carbon atom which is attached on the benzene ring, this carbon atom, which because it is having a double bond here and halogen here, this particular bond, it is sp2 hybridized. sp2 hybridized with halogen atom. sp2 has higher electronegativity. Halogen also has higher electronegativity. So what happens is that this halogen atom could not attract as much electron as it could have attract from sp3 carbon atom, which is generally the case of haloalkane. And when the carbon atom it is attached with halogen atom, this gets a delta positive charge. And because of this delta positive charge, the nucleophile attacks here. But in this case, if the halogen atom is not able to attract the electron because of the higher electronegativity of sp2 carbon atom. And that is why the nucleophile cannot reach the carbon atom, the alpha carbon, and attack. So these are the reasons. Now I will write this down. Just let me know if you do not understand any one of those 4 points. Okay, so I'm writing this down. Once you write it down, then just let me know. I will explain it once again. Partial double bond. लिखते जाइएगा समझ में आता जाएगा ऐसे भी. Partial double bond. One reason is the partial double bond at CX due to resonance is difficult to break. Next reason is that the phenyl carbocation is unstable. Third is repulsion between electron-rich nucleophile and benzene. Fourth reason is the sp2 carbon of CX bond doesn't have enough partial positive charge to attract nucleophile. Let me know if I need to re-explain any one of these points. for Amna and Taha. Now, so these are the problems. If you want to do nucleophilic substitution reaction, which everyone is done. Okay. Nucleophilic substitution reaction with haloarine. So there are a few conditions in which we can do nucleophilic substitution reaction. First thing is that if I can break the CX bond, and how can I break the CX bond? By giving high temperature and high pressure. When I give high temperature, then the CX bond can easily break. And if I give high pressure, then in that case, what is going to happen? The nucleophile will eventually get near the haloarine atom, the carbon atom of haloarine, and then the reaction will happen. Because at high pressure, what's going to happen? The compounds of the molecules are going to be very closer together, right? So at this particular condition, at high temperature and high pressure, haloarenes can show SN. One more condition is that we can place electron withdrawing group, and how it is going to help, we are going to explain that also. यहाँ पे लिखिएगा सबसे पहले बात that haloarine can show SN at two conditions. The number one is at high temperature and high pressure. It is drastic condition. Second, place electron withdrawing group at ortho or para position. So when we place electron withdrawing group at ortho and para position, they will reduce the electron density in the benzene ring, and the nucleophile easily attack on the carbon atom. Nucleophile was not going near the benzene ring or the carbon atom of benzene ring, because benzene ring it has very high electron density. Nucleophile is having high electron density, so both of them are going to repel each other, right? दोनों में क्या हो जाएगा? Repulsion हो जाएगा, right? So if I place electron withdrawing group, then it can reduce the electron density, and the nucleophile will come closer. So first thing is that, let us suppose we have haloarine like this, benzene ring bonded to chlorine. Here we have aqueous NaOH, 623 Kelvin. atm pressure. First, it gets converted to phenoxide ion. Then, because it is basic condition, if you add H positive, it will get converted to phenol. So high temperature and high pressure. Now you can start adding electron withdrawing group. So for example, we can add NO2 group in the para position, let's suppose. Chlorine. Now in this first step, I'm adding aqueous NaOH, and then 43 Kelvin. Second way, I'm adding H positive. So in this, if we add NO2, then we just need a small amount of temperature, and we don't need any pressure right now. Here we will directly get OH, and NO2 will be there in the para position. Now we can add NO2 in the ortho and para both the position. NO2, NO2. Aqueous NaOH. The temperature is again smaller, 368 Kelvin. Second step is H positive. The NO2 will be as it is. And instead of chlorine, you will have OH. Last one is, in both the position, you can have NO2 group. If you're not written, don't worry, I will give you time to write. So instead of NaOH, you can have KOH also. And this just need a little warm type of temperature. Second step is H positive, and we'll get everything as it is. Instead of chlorine, there will be OH. And the NO2 will be as it is here also. So you can write this for reactions of the nucleophilic substitution reaction of halorine. Your hand once you're done writing. Waiting for Sufyan. Now, let us see how this particular NO2 is working. By the way, इसका नाम लिख लीजिएगा. This last one, it is known as picric acid. Okay, it comes. You can write picric acid. Now, like what is the electron withdrawing group, that is the NO2 group, doing at the ortho and para position? How it is stabilizing, or how it is increasing the reactivity of the reactant. ठीक है, थोड़ा सा mechanism type का, बस इसको देख लीजिए. Don't need to remember this too much. Here we have chlorine, and from NaOH, what is going to happen? From NaOH, OH negative will be there, and the OH negative will act on the carbon atom. So as the OH negative is attacking on the carbon atom, oxygen is forming a new bond with this carbon atom. So this carbon atom is going to break its weakest bond. So here we have two types of bonds, sigma and pi. It is going to break the pi bond like this. And what's going to happen? Fine. And this pi bond will be now negative charge. So as you can see, there is a negative charge at the ortho. And if I draw one more resonating structure, so this negative charge will come down here. This pi bond will shift here. The second resonating structure will look something like this. The chlorine and OH is as nothing happening here. The double bond is here. The negative charge has come down here. The double bond is here. If I draw one more, then you can see that the pi bond is again getting to negative charge, and it is at the ortho position. OH and Cl. Here we have negative, here we have double bond, here we have double bond. So you can see that from these particular structures, the intermediate has negative charge at ortho and para positions, and placing electron withdrawing group at ortho and para position increases stability and also the reactivity. Write this down and raise your hand once you're done. Just waiting for Sufyan. ठीक है, चलिए. So all the reactions of halorine is done. अब एक बात बताइए आप लोग, have you done this topic, chiral carbon or enantiomer, diastereomer? Are these topics done in nucleophilic substitution reaction in SN? Mariam, Taha, anyone?
No, sir.
So
No,
a
sir.
carbon atom which with 4 different groups, like for example chlorine, hydrogen, fluorine, and bromine. This atom will be called as chiral carbon. ऐसा कुछ किया आपने?
यस सर, वो ऑप्टिकली एक्टिव, ऑप्टिकली इनएक्टिव, रैसमिक मिक्सचर, वो सब ना.
हाँ वो सब जिशान सर ने करा दिया है.
नहीं हमने स्कूल में किया था.
स्कूल में नहीं, लर्निवियो में. हाँ सुफियान नहीं
नहीं.
नहीं किया है. ठीक, चलिए टॉपिक डालिएगा खैरा. थोड़ा सा आपको अजीब लगेगा ये टॉपिक, ठीक है ना, लेकिन क्या आते हैं, दीज द क्वेश्चंस आर वेरी इजी. क्वेश्चन कोई सा भी, बट दिस इज वन ऑफ दोज टॉपिक्स तो मतलब थोड़ा सा ऑड टाइप का लगेगा आपको, बट इट इज नॉट, द क्वेश्चन नॉट हार्ड. ठीक है, सिंपल. सबसे पहले हम लोग मतलब वी आर गोइंग टू डाइव इनटू डायरेक्टली हाउ द क्वेश्चंस आर गोइंग टू कम. फर्स्ट थिंग इज chiral carbon. What is chiral carbon? Carbon attached to 4 different atoms or groups. 4 different atoms or groups. For example, CH4. So in carbon, in this carbon, all the atoms are what? This carbon is attached to only. This carbon attached to only. Tell me, guys. It is attached to only. अरे बोलो यार.
H.
H, hydrogen atoms, right? So it is only attached to one type of one atom or one group, not 4 different atoms or 4 different groups, right? So this is not a chiral carbon. What about this one? Is this chiral?
No, sir.
No.
No, sir.
What about this carbon atom? This red carbon? This is Br. What about this red carbon atom? This is CH3 and
Yes.
CH3, na? These are CH3. This is CH3. What about this carbon? Is it attached with groups?
No.
Sir.
No, no. See, this CH3 and this CH3 is same. And there is one atom which is not shown here, which is hydrogen. ठीक है, तो ध्यान रखिएगा. अब जैसे मान लीजिए आपके पास एक और एग्जांपल दे रहे हैं. What about one atom?
Yes. It is.
Mariam, क्या ख्याल है आपका? Can you see? Is it?
Yes, sir,
Taha?
it is.
It is, right? देखिए. Now can you tell me what are the groups attached? What are the four groups? Four groups ना Mariam?
Yeah,
ठीक है,
one
बताइए
is
जरा.
one is hydrogen down,
हम्म
one is Br,
हम्म
one is CH2, and one is CH3.
CH2 and CH3. नहीं. This
Right.
is one group. Now, this complete
Okay.
thing is one. This is C2H5.
Okay.
And then here we have methyl, this is CH3. Okay. Taha, Taha?
Yes, sir.
Yeah. Fine. So, chiral carbon हो गया. Now, molecules that have chiral carbon are called chiral molecules. Although, I mean, if you have two chiral carbon atoms, then the chirality may be cancelled and they will be achiral, but that is not, we are not going to go into that much detail, and it is not even required. So if there is a molecule which has a carbon atom, molecule may have multiple carbon atoms. If any one of the carbon atoms is attached with four different groups, then the molecule itself is a chiral molecule. ठीक है? Write this down, raise your hand if you're done. Who's still writing? Taha, let me know once you're done. Taha. Done? Right question. Identify the chiral and achiral molecules in each of the following pairs. है ना? In these two, which one is chiral? You have to identify that. कर लेंगे मरियम, सफियान?
Yes, sir.
लीजिए। Oh, I have got the answers. I, Mr. Taha. Taha, am I
Yes, sir.
audible?
Yes, sir.
ये में आपने बोला chiral, दोनों chiral है? Both of the structures are chiral.
No, sir. Wait, hold on.
Okay. Mariam, हाँ. What happened, Amna? You got disconnected.
यस सर।
क्यों? इंटरनेट सही नहीं है?
जी थोड़ा प्रॉब्लम हो रहा है नेट में।
अच्छा।
And I'm not sure about B.
ओके, ठीक है, बी वाला ठीक है, सब सही है. एंड सो इज दिस सुफियान. सुफियान, correct. The first one is correct. The second one is also correct. The third one is also correct. Yeah, very good. That's okay. The first one was quite easy. You can see that in the A structure, the first structure is having all the four groups are different. So this will be chiral. And here we have two same atoms. That is why it is chiral. It is not chiral. In the second one also, you can see that one, two, this is the third group, and this is the fourth group. All of the four groups are different. So this is chiral. Here you can see that there are two ethyl groups on the same carbon atom. This carbon has ethyl group. So these two are same. And if it is same, it is going to be chiral. And that is why we do not need to see this. Here you can see that this is this particular carbon atom, it is chiral. It is having Br, a methyl group, and ethyl group is one hydrogen. This is chiral. And here, if you look at like all of the other carbon atoms, they are going to have CH2. Even this carbon atom is going to have CH2. And there are two hydrogens. That is why it is not chiral. It is also done, guys. Sufyan, Taha. चलिए, अब एक और डेफिनेशन. एक तो इस तरह के सवाल आएंगे ना. The other question that can come like from this particular topic is definitions and all. ठीक है, तो write some definitions. ठीक है, ध्यान से सुनिएगा बस. एक बार आपको सुनना है, then you just need to revise it. These particular definitions are not going to be used anywhere else. Right? हल्का सा बस आपको दिमाग में रहना, कहीं पे भी अगर आपके पास ऑप्टिकली एक्टिव आ गया वगैरह, तो उसका हल्का सा दिमाग में बस रखना पड़ेगा आपको. ठीक है, तो द डेफिनेशन इज फर्स्ट वन इज ऑप्टिकली एक्टिव. You hear this term optically active. What is the meaning of this term optically active? The compounds that rotate plane polarized light also known as PL in clockwise or anti-clockwise direction are called optically active compounds. ठीक है, ध्यान सुनिए जरा. We have light and the light is not polarized. That means it is not in a particular direction, and it has frequencies and the vibrations of that particular light is in all the directions. Now, then we should have a Nicol prism. This Nicol prism, it doesn't do anything. ये क्या करता है, जो हर किस्म की जो light है in all the direction, it polarizes it. What it does is that it gives you one light in a particular direction. The light wave will be in only a particular direction. So it is polarized for one direction only now. If you pass this particular light from a optically active compound, a solution of optically active compound, let us suppose this is solution of optically active compound. Solution of optically active compound. Then what happens? This optically active compound, it rotates the plane polarized light by clockwise in anti-clockwise or anti-clockwise direction by some degree. And this particular rotation can be measured by a device which is known as polarimeter. This is polarimeter. इसको बस लिख लीजिए, इसमें क्या क्या सवाल आने लाइक वेरी स्मॉल थिंग ना, कि प्लेन पोलराइज्ड लाइट इट कैन बी रोटेटेड बाय ऑप्टिकली एक्टिव कंपाउंड एंड द रोटेशन कैन बी मेजर्ड बाय पोलरिमीटर. ठीक है, तो इस पर्टिकुलर सीन को बस आप दिमाग में रखिएगा. राइट दिस डाउन, रेज योर हैंड. Let me write it here that this is Nicol. This is plane polarized light. Waiting for Amna and Mariam Batul. Waiting for Amna. Amna है या नहीं? Amna, are you there in the class? ये सिर्फ आमना की आईडी लगी हुई है यहाँ पे. Seems she is not here. Connection नहीं है. Fine. You can write a point. Polarimeter measures the angle by which plane polarized light rotates. Now, this rotation of PPL can be clockwise or it can be anti-clockwise, है ना? दोनों डायरेक्शन में रोटेशन हो सकता है. It can happen in clockwise or anti-clockwise direction. So in clockwise, if the compound rotates the plane polarized light in direction, then we say that it is dextro-rotatory. The compound is dextro-rotatory. Rotate, or we denote this by plus sign, or we call that it is the D form of compound. If it rotates anti-clockwise, we call it levorotatory. Rotatory. And denote it by negative sign, or L form of the compound. And if a particular molecule, if there are two molecules, they have same same molecular formula, same structural formula, but they only differ in the direction by which they rotate the plane polarized light. So, for example, we have certain compound, it has same molecular formula, same structural formula also, but it rotates sometimes clockwise, anti-clockwise. Then obviously there are two compounds, and these are the compounds which are known as optical isomers, because they do not differ in anything. These compounds only differ in the way or in the direction in which they rotate the plane polarized light. Okay, this will clear. Then we will write the definition of optical isomers. So the compounds, the dextrorotatory is a type of compound. Hai na? The compounds which rotates the plane polarized light in clockwise direction will be dextrorotatory. The one which rotates in the anti-clockwise direction will be levorotatory. Raise your hand once you're done. देखिएगा the compounds with same molecular formula and structural formula but differs in the direction of rotation of plane polarized light are called optical isomers. ठीक है ना? These definitions are important. देखिए इसमें ना, like in this particular topic, what I require all of you guys is to memorize the things. If you get too deep in this particular topic, this is one of those topics from the chemistry class in which people can do PhD also. Like literally, they do PhD optical activity and not optical isomers as such, but if I go into the details, when the drugs are made, I mean the matlab medicine, है ना? So when medicines are made, they are made of a particular isomer, and there has certain optical activity. And if there are two molecules of the drug which is possible, then we have to check which of these drug molecule, the two structure which are possible, one is rotating the light in the clockwise direction, the other one is rotating in the anti-clockwise direction. Then we have to see which is suitable for the body. Okay? So if you get into the detail, it is too much. Too much matlab too much. So what I need you guys to do, देखिए कोई relation here, but all of these is under the chirality topic only. The chiral molecule which we saw, first of all chiral carbon, वो आपको आना ही आना चाहिए. If you have studied with some seriousness in Halogen chapter, And the one thing that you should know about chirality is that how to identify a chiral carbon, how to identify one chiral carbon, and then the questions. Because majority of the times, if the topic is chirality, the question will be identify the chiral molecule or identify the chiral carbon. वो आना चाहिए आपको. Then there are the definition that you should know. Okay, fine. Something is known as plane polarized light, or what is optically active compound, and what is polarimeter. And if the plane polarized light it rotates in the clockwise direction, then we call that molecule dextrorotatory or plus or deform anti-rotate. All of these things you should know. Up once again, see, this is what we are done here in chirality and the chiral carbon or the chiral molecule. I have told you how to identify them. सवाल होगा identify कैसे करना है. Now comes the definition. If they ask what is chiral molecule, then whatever I am going to write now, that is going to be the definition. This is how to identify. Initially, what we identified the chiral carbon and we identified the chiral molecules. अब जो हम लिखाने जा रहे हैं chiral molecule की definition है, ठीक है? Please write this with me. Chiral molecule. You may not see any similarity in identification and the definition, but please इसको ऐसे ही लेके चलिएगा, and that will help you. तो अगर आप डूब गए इस टॉपिक के अंदर फिर तो बहुत दिक्कत होगी. ठीक है, ये 1 घंटे का टॉपिक है. whenever you are revising, give it like 1 hour or even less than 1 hour. Revise the definition, some problems on identification of chiral molecule. That's it, खत्म बात. What is chiral molecule? ठीक है, 3 स्टार लगा दीजिए. chiral molecule, if they ask, you have to write this particular statement, not the previous one. That one was only for identification, how to identify chiral molecule. Please write it with me. Tool which is not superimposable on its mirror image is called chiral molecule. For example, we have a carbon atom. Please don't draw this molecule right now. And it is attached with 4 different groups. Let us suppose this is S, this is P, this is Q, and this is R. And let us suppose we have its mirror image. Carbon. Then we have S. The mirror image will be P, this will be Q, and this will be R. Okay? Now, these two mirror images, if you are going to overlay it on each other, you can see that it cannot be overlaid. Even if you rotate it, it will not be overlaid. है ना? बस इसको आप ऐसे समझ लीजिए. No need to go into too much detail. You know, time waste होगा इसमें, ज़्यादा सवाल आते नहीं हैं आपके. Now, these two are what? These are molecules which are mirror images, but these are not superimposable on each other. So both of these molecules are chiral molecules, and they have a relationship. These type of molecules, these are ये एक दूसरे के cousin हैं. Cousin तो नहीं है, है क्या है? Enantiomer. ठीक है? So if this is A and this is B. So if they ask you, what is B? So B is a chiral molecule. But if they ask you the relationship between A and B, so you will say enantiomer. और समझ में आ रही है? Should I repeat this? For example, मान लीजिए सुफियान से पूछा गया, सुफियान आप कौन है? तो मेजोरिटी ऑफ द टाइम सुफियान क्या बताएंगे? अपनी निस्बत अपने फादर से करेंगे, लाइक हम उनके बेटे हैं, राइट? बट अगर सुफियान से उससे पूछा गया, सुफियान तुम और मान लेते कोई एक लड़का है उनका, कोई कजन है आपके सुफियान, कैन यू नेम वन ऑफ योर कजन? बोलो भाई, सुफियान कैन यू नेम वन ऑफ योर कजन? नहीं आवाज आ रही है. मरियम, मरियम अपने कजन का नाम बताएं। मरियम
जी सर।
अपने कजन का नाम बताइए ना, कजन का नाम।
ओके, जोया।
तो इफ आई आस्क मरियम हु आर यू, हु इज मरियम इन जनरल, इफ आई आस्क, एक जनरली नहीं, हु आर यू हम आपसे नहीं पूछ रहे, इन जनरल इफ आई आस्क हु इज मरियम, then if Mariam is there, she will say that I am daughter of, she will tell her father's name. But if I ask Mariam और Zoe relation है, they will say मतलब they will say cousin, right? तो B क्या है? Chiral molecule. A क्या है? Chiral molecule. They have their own, not names, but rather they have their own identification. But what is the relationship between A and B? A B का क्या है? So we say that they are enantiomers of each other. They are enantiomers of each other. Enantiomers के अंदर की एक और बात ये होती है, if A rotates PPL 60 degrees clockwise, then B rotates PPL 60 degree anti-clockwise. बात समझ में आ गई? ठीक है, तो इसको हम ये तो लिखा नहीं है. What are enantiomers? लिखिएगा, enantiomers are non-superimposable is, अगर कोई पूछे ना बी enantiomer है क्या, बोलेगा पता नहीं. अगर हमसे पूछा जाए मरियम कजन है क्या, हम क्या बोलेंगे? पता नहीं. अरे भाई किसकी का बताओ. ये बात समझ में आ रही है? कैन यू अंडरस्टैंड व्हाट आई एम ट्राइंग टू से हियर? इफ दे आस्क यू इफ B enantiomer is B an enantiomer and if they have not given you any amount with which you can relate it, you say no. How would I know B is an enantiomer or
They
not?
will ask like, is B an enantiomer of A, like this?
Then it is true. B is an enantiomer of A, then it is true. ठीक है?
Yes, sir.
Right here. Give me a second. Just give me a second, guys. Okay. So enantiomers are, देखिएगा, so non-superimposable mirror images. Next point. Enantiomers rotate plane polarized light in opposite directions with same magnitude.
अभी आप सर एक मिनट ऊपर कर सकते हैं इसको.